All right, question 3 on the worksheet says, what's the domain of the function g of x, which is equal to x squared minus 3x minus 4, all divided by x minus 3? And then it asks to rewrite this function by performing a long division. Okay, so when it's asking for the domain, it's, in other words, asking for what values of x is our function g of x to find. And so just like in question 2, we want to look out for values of x that will result in a division by 0. And since our denominator here is x minus 3, we see that if x equals 3, we're going to have a problem, right? We're going to have that division by 0. So for our domain, this will consist of all values of x excluding 3. So I can just write that as x cannot equal 3. Okay. Now the other part saying to rewrite the function using long division. So I'll go ahead and set up our long division here. X minus 3 is dividing into x squared minus 3x minus 4. So x and the x squared would be x. And then distribute. X times x is x squared. X times minus 3 is minus 3x. So go ahead and subtract by changing signs and adding. And notice here, everything is going to drop out. I'm just going to get a 0. Okay, so here I'm going to go ahead and just carry down the minus 4, and that is the remainder. Okay, so we can say this, that g of x is equal to our quotient, which is x, and then our remainder is a minus 4, so I'm going to write that as minus 4 over x minus 3. And then just for emphasis here, I'm going to put in that domain restriction, x cannot equal 3. Okay, so this would be the result of our long division. And that does it for this problem. But I do want to mention one more thing here as kind of a lead-in to question 4. If I pull up the graph of our function g of x, okay, notice at x equals 3, we have a vertical asymptote. Okay, and the reason for that is because of this remainder term. Okay, if I plug in values for x that are close to 3, this denominator is going to be infinitely small. And if I divide 4 by something infinitely small, I'm going to get output values that become infinitely large. Okay, so what I want to now do is contrast our result for part 2 to what we're seeing now here for part 3. Okay, so if I have a general rational function, okay, so the numerator I'll call the dividend, the denominator's the divisor. If the remainder comes out to be 0 after we perform a long division, which is what happened for question 2, then what we saw there was that we had a hole in the graph. Okay, so when you did this long division, we got just x minus 1 with no remainder term, and y equals x minus 1 is just a straight line, but we just had to remove this one single point because of that domain restriction. Okay, and what we're seeing now in problem 3 is that when we do long division, we do have a remainder term, and now that's giving rise to this vertical asymptote. And again, it's because of this remainder term. Values of x that are close to 3 will produce infinitely large outputs. All right, that's going to do it for this question. Thanks.